9.4, guys, part 1 and part 2. We're going to talk about graphing parametric equations. And then tomorrow we're going to talk about eliminating the parameter. Now, this sounds a lot more difficult than it is. This is a concept that we're not going to get too deep into, right? This is a concept we use in physics and stuff like that, but we are not going to get too deep into it other than understanding the mechanics behind, right? Up to this point, we've been representing a graph by single equations that have two variables, right? Such as x and y. In this section for 9.4, we're going to introduce a third variable, and it's going to represent a curve in a plane. All right, so we're going to have three variables. There's going to be an x and a y, and then a t. Okay, everybody understand? All right. So, a lot of times you'll see a problem like this. When the initial velocity of an object is 48 feet per second, it'd be shown that the object flows at this parabolic path. So you would plug in stuff for your x and your y and figure that out. These are parametric equations. Notice in these parametric equations, do you guys see the x and the y? And what do they both have in them? T, all right? This is all in regards to time. So what we're going to do, we're going to do two things. We're going to, today, we're going to graph the parametric equations. So we're going to make some sort of a curve, something like this. Tomorrow, we're going to take our parametrics and turn them into rectangular, which all you do is you take one of the equations of the parametrics, one of the x equals and y equals, you solve it for t, and then you substitute into the other equation. I'll show you a little bit what I mean in a second. But it's really, the mechanics behind this is simple. So what is also important here, if you notice, what is on this graph? Not only is it a graph on an xy, but what does it show? What does that little arrow show? That shows the direction, right? That's called the orientation. You're going to have to be able to tell me the direction that your curve is moving. And I'll show you how to do that in just a second. All right. It does tell you, when you have these parabolic equations and stuff like that, it tells you where an object has been. But it does not tell you when the object was at a given path. You can't just like put your finger on a curve and say, oh, this is exactly the point in time that this was. It just gives you like an overarching value. Again, that doesn't mean anything to you guys. I understand that. But to determine this time, this is our third variable, right? It's called a parameter. Sometimes your parents give you certain parameters. They're like rules. They're guidelines. We use these parameters to plug in our x and y of our parametric equations. Again, I understand you guys are like, what? Just relax. This is the parametric equation for x because it has an x in it and a t. This is the parametric equation for y because it has the y and the t. Everybody see that? Yes or no? Okay, so what we're going to end up doing tomorrow is to change these from parametric that have t's in them to rectangular with just x's and y's. You would solve one equation for t. Which would be easier to solve for t? The top one, yellow or blue? Yellow. Okay, so what would we have to do? Well, first thing you would do is divide by 24, right? Correct? So you have x over 24 equals the square root of 2t. Then what would we do to both sides? Square both sides. So you have x over 24 squared equals 2t. And then what? Then divide by 2. Then you would take this and you would plug it in for t in the other equation. We're not going to do anything that involved, but that's the concept. You're going to solve one equation for t and then plug it into the other one. Nothing is involved with that. I just want you guys to see. Again, we're talking about a plane curve. On some of your web assignments, it's going to be a straight line because they're super, super basic, but the ones that we do are going to be a curve. It's a continuous function, which means the graph can be traced without lifting your pencil or whatever. This is just your math jargon behind it. Let's go on to actually how to do this. All right, I want to show you promise you how easy this is. What I really need you to focus on, all right, we're going to graph on an XY plane. We are going to get our XYs from the given parameter. And some of you are like, what are you talking about? As soon as I do this in a second, it's going to make complete sense. But it says by plotting the resulting points in order of increasing values. Everybody see that? Increasing values. You are creating the orientation of your curve. That means the arrows, the direction. So you're going to see a problem that's going to say, describe the orientation. And if you don't know what that means, you're going to be like, what? All that means is, hey, from the starting point to the ending point, draw little arrows. Right? That's the orientation. So here we're going to do 2 examples and then we're done. This is what I'm going to need to see from you on your quiz. You're going to have 1 or 2 of these from 9.4 and then the rest is going to be from 9.5. And this is exactly what I need to see. The first thing we're going to do is draw a little chart. I might actually even draw the chart for you just to keep you a little more organized. Okay, here's our chart. My first column here is T. My second column is X equals. My third column is Y equals. And my fourth column is my XY. Remember, T is the parameter, the given values that they want me to evaluate with. Do you guys see those? What are they telling you right here that they want you to use? -2 to what? +3. So over here, I'm going to write, okay, I'm going to evaluate with -2, -1, 0, 1, 2, and 3. And you guys are like, evaluate what? I'm going to evaluate each one of my equations. I'm going to evaluate my x equals equation with -2. I'm going to find the x part of the point. Then I'm going to evaluate the y equation with -2. I'm going to find the y value of my ordered pair. So we're just going to be doing a lot of plugging in here. That's it. I'm going to take all of my values for t and plug it into t squared minus 4. I'm going to take all of my values for y and plug it into t over 2. Anybody have any questions so far? All right, so this is what I need to see. I need to see it on WebAssign. I need to see it on your quiz. I need you to say, okay, I'm plugging in -2 squared minus 4. What is -2 squared, guys? 4, and 4 minus 4 is, so the x part of my first point is 0. Now I'm going to do the exact same thing, but I'm going to plug in what, where? I'm going to plug in -2 into the y. So it's -2 over 2, which gives me -1. So your first point that you're going to plot is at 0, -1. And we're going to continue to do that to find all of our points. So now I'm going to plug in -1. So I have -1 squared minus 4. What is -1 squared minus 4? -3. Perfect. And now I'm going to say -1 over 2 just gives me -1/2. That's fine. Now what am I going to plug in? 0. So 0 squared minus 4. What's 0 squared minus 4? -4, comma. I'm going to plug in 0 for t. So what's 0 over 2? Perfect. Now we're going to plug in what number? 1. So 1 squared minus 4 is -3. And then I'm going to plug in 1 here. So 1 over 2 gives me 1/2. Perfect. And now I'm going to plug in 2. 2 squared minus 4 is, right? 2 squared is 4 minus 4 is, good, 0. And now I plug in 2 here. So 2 over 2 gives me 1. And then this, we got to take a little bit of work here, yeah? What am I doing with 3? 3 squared minus 4. Well, 3 squared is 9, and 9 minus 4 is, okay. And then here I'm plugging in 3, so I get 3 over 2. You can leave it as 3 over 2. If you want 1.5, that's fine. That is the first part of graphing your parametric equations. You have used the parameters given, the values they want you to plug in for t, and you have found the x and the y part of the coordinates. Does that make sense? Yes or no? All right, a little thing I might tell you to do, I'm going to write the word start here, and I'm going to write the word end down here, just so I know the direction that I'm going. So when we plot our points, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. -2. Where is my starting point, guys? Okay, so I have a point here at 0, -1. Where's my next point? -3, -1/2, okay. -4, 0. -3 and 1/2. 0, 1. 5 and 3/2. All right. And then we just connect in a nice smooth curve. Now what you have to remember is your orientation. Where did you start? You started here, right? And you ended up here. So what direction are you going? You're going in this direction. And that's it. You find your x and y. How do you find your x and y? Well, you use the parameters that they gave you. And then once you find your x and y, you plot your points, you draw your curve, and then you make sure your arrows are going from the starting point to the end point. Does that make sense? 5 minutes ago, you would have been like, what? Now it's like, oh, this is easy, just to understand. So look, here's the second problem. Sketch the curve and describe the orientation. Do I want you to write me a paragraph? No. Draw arrows. So how do we sketch the curve? First of all, draw your chart. So t, x is 4t squared minus 4. Y equals t, that's easy. And then you have your x and your y. What are the t values they want you to use? -1 to what? 3/2. So I'm going to go -1, 0, 1, and what? 3/2. So let's evaluate. Plug in -1. So 4 times -1 squared minus 4. What's -1 squared? 1 times 4 is 4 minus 4 is 0. Doesn't always start at 0, -1. And now I'm going to take -1 and plug it in for t, so I get what? A -1. Good. Now we're going to plug in 0. So 4 times 0 squared minus 4. What's 0 squared? Times 4 is 0 minus 4 is -4. And then when I plug in 0 for t, I get out 0. Okay. Let's go with 1. 4 times 1 squared minus 4. What's 1 squared? 1 times 4 is 4. 4 minus 4 is 0. And then I'm going to plug in 1 for t, and I get out 1. All right, a little bit of math we got to do here. But I have 4 times 3/2 squared minus 4. Guys, when you square 3/2, it becomes 4/1 times 9/4, correct? Minus 4. What happens to the 4s? They cancel. So you end up with 9 minus 4, which is 5, comma. When you plug in 3/2 for t, you get out what? 3/2. Now you have discovered the first set of information that you need. You have found your x, y that you're going to plot. You found your points. So let's go ahead and make a little. All right, where's your starting point? Where's your end? You don't have to do that. I just think sometimes it's a good idea so you don't get yourself lost. But where are we starting? 0, -1? Okay, so 0, -1. And then I'm going to -4, 0. Then I'm at 0, +1. And then at 5 and 3/2. So something like that. And then when we connect, what is the orientation? From your starting point, which is here, your ending point is here, what direction are you going? You don't even have to say it, just draw little arrows. Now, your web assign is not long. You can start some of it now, but a lot of you are going to have questions like, wait, I don't know how to do this. I will finish explaining this tomorrow, but you're welcome to start if you want to. But